Equations. The best way and the easiest way to balance chemical equations is to follow the steps that I am going to give you. When you look at the chemical equations, start first counting the atoms on both sides of the equation. So, on the reactant side, we have magnesium, and we have one atom of magnesium, and oxygen, we have two atoms of oxygen. On the sides of the products, we have one magnesium and one oxygen. So now you will compare and look to see which atoms are not balanced or are not equal. We can see that oxygen, we have two on the reactants, so we decide to multiply on the product side by 2. And this number that we decide to multiply with, we need to write it over here. So once we multiply by a coefficient, we recount the side where we did the change. So now magnesium is not anymore 1. We now have 2 magnesium atoms and we have 2 oxygen atoms. Oxygen is balanced, but magnesium, we need to rebalance it on the reactant side. So we multiply the 1 magnesium by 2, and this 2 is the coefficient. We write it on the side next to magnesium. Let's take another example. Let's split the equation between reactants and products. On the reactant side, we have 1 phosphorus and we have 2 oxygen atoms. On the other side, we have 4 phosphorus atoms and 10 oxygen atoms. So we start counting and comparing. Now, first of all, oxygen, I have 2, while here I have 10. So I need to multiply the 2 by 5 in order to get 10 on both sides. And this 5 is a coefficient that I must write next to the oxygen as a coefficient. Now, we need to now count the phosphorus. Oxygen is now balanced. Looking at phosphorus, I have 1 and I have 4. So I multiply this side by 4, and this 4 is the coefficient that you place next to phosphorus. Now phosphorus is 4, balanced. The side where you did not multiply, you can leave it empty or simply write 1. And that's it. Let's take another example. Let's split the reactants and products and count the potassium, the chlorine, and the oxygen atom on each side of the equation. So on the reactant sides, I have 1 potassium, 1 chlorine, and 3 oxygen. Whereas here we have 1 potassium, 1 chlorine, and 2 oxygen. Now, obviously, the oxygen is the side that is not balanced. So we decide to multiply this by 2 and the product side by 3. Now, 3 and 2 are coefficients to place over here. I'm multiplying the O, so I write the 3 on this side. And after we do our calculations, our multiplication, we recalculate. So now I am going to recalculate. I have 2 potassium, I have 2 chlorine, and now I have 6 oxygen. Now, here only the number of oxygen changed to 6. Now oxygen is balanced, but as you can see, the potassium and chlorine is not anymore balanced. So if I multiply the potassium by 2 and place this coefficient here, I will obtain 2 potassium and 2 Cl. So this is 2 potassium, and when I recalculate or recount the Cl, now I have 2 Cl. All atoms are now balanced. Let's take 2 more examples. Let's split the atoms in the periodic table, in the equation between reactants and products. Carbon, we have 1. Hydrogen, we have 4. And oxygen, we have 2. Now on this side, I have carbon, 1 atom. I have oxygen on 2 sides. I have 2, and on the other side, I have 1. And hydrogen, I only have 2. So now, let's start balancing. First, we start by the unbalanced atoms, and let's take the easiest. Hydrogen, I have 4, and here I have 2, so I will multiply by coefficient 2, and this 2, I'll write it over here. This is definitely going to change the number of the hydrogen here. It's going to become 4 balanced, but it will also change the number of oxygen here. Instead of having 1 oxygen, it's going to be 2 oxygen in 2H2O. And now let's balance the oxygens. On this side I have 2, but on the product side, the total of oxygen coming from CO2 and coming from H2O is 4. So I need to multiply the reactant by 2 in order to get 4 oxygen on each side. Now this is a coefficient that I am going to write it over here. And carbon is balanced and my equation is balanced. Any coefficient, if you leave it empty, it's okay, or you can simply write 1. The last example, balancing aluminium oxide, decomposing into aluminium and oxygen. Now counting aluminium, I have 2 atoms in the reactants and 3 atoms of oxygen in the reactants, whereas in the product side, I have 1 aluminium and I have 2 oxygen atoms. First, let's start balancing the oxygen. This is 3 and this is 2. So I'm going to multiply by 3 and write the 3 over here and multiply by 2 and write the 2 over here. Like this, we managed to balance the oxygen. Now by placing this 2 over here, the coefficient, the number of aluminium changed. Instead of being 2, now we have 4 aluminium. Therefore, we need to multiply the aluminium on the product side by 4 to have 4 of aluminium on every side.